This is a question from the 2008 paper. It's question 10b. Define oxidation in terms of electron transfer. Think of the acronym, not the acronym, mnemonic, OIL. OIL rig, oil for oxidation, rig for reduction. But OIL is loss of electrons. So oxidation is, sorry, not oil is loss. Oxidation is loss of electrons. That's what the OIL stands for. Change in oxidation number. Oxidation loss of electrons, and electrons are negative particles, so it means an increase in the oxidation number. Part 3, well, that just involves identifying the species oxidized and then the oxidizing reagent in the second reaction. So let's dip into those reactions now to enable us to answer those questions. So here's one I prepared earlier. Here's the equation written out, and I'll assign oxidation numbers to it now. Oxygen's -2. It's the more electronegative of the two, so it's still its usual -2, whereas chlorine, a halogen, normally -1, is now, because of the overall charge of this molecule is -1, is chlorine is +1. Iodide -1, hydrogen we don't need, chlorine -1, iodine 0. So let's set up a table of what's changing. Cl is changing. It's going from +1 to -1, and iodine is going from -1 to 0. So I'm going to look at the difference. Get a ratio, and then make sure we're balanced. So we've got chlorine going from, there's a change, it's a gain of 2 electrons, and then iodine going from -1 to 0, it's a loss of 1 electron. Cross multiply 1 and 2. So we need 2 iodine atoms to satisfy 1 chlorine atom, just to make sure our budget is kind of balanced. Gain of 2, loss of 1, so we need this ratio to make that relationship work. And then balance, how are we doing for atoms? We've got 2 atoms of iodine there, so we're going to have going to need 2 of those, and then we'll need to apply a factor of 2 to chlorine as well to keep this ratio constant. And then total atoms of chlorine is 1 by 2 is 2, and iodine 2 by 2 is 4. So we've got 2 chlorine on the left, 2 on the right, and iodine we've got 4 on the left. We've already got 2 on the right, so we just need a coefficient of 2 there. And let's see how we're doing for the other atoms in this equation. So we've got chlorine and iodine sorted already, but we need to take account of oxygen and hydrogen, need to balance those. So we worked out the first 2. Now oxygen, there's 2 already here on the left. So I need 2 on the right. Right, okay, that's terrible. I'm missing an oxygen. Did I delete that, or did I not write it? I'm not sure. Okay, that's only where my oxygen was. So I need 2 on the right as well. Okay, and that alters my hydrogens. That's 2 by 2 is 4. I've got 4 hydrogens there, so I need 4 over here. Okay, that's balanced. Now, I need to identify the species oxidized. Oxidation, as I said initially, oxidation is loss of electrons. What's losing electrons? Iodine. So species being oxidized is, okay, that one here. Or sorry, I could right up here. That one's being oxidized. Now we need to move on to the second equation. Give myself some space down here. Oh, need to be able to see it. I2. Oxidation numbers, got 0 there and -6 here, and the overall charge is -2. So this would be, sulfur would be 4, but there's 2 of them, so it's +2, and iodine -1, and then oxygen is -2, and there's 6, so it's -12, and then overall charge is -2, so I need this to be 10, but there's 4 of them, so it's actually +2.5. And I multiply that by 4. Just like, sorry, I shouldn't say multiply that by 2 as well. Okay, so we've got a decimal place oxidation number, if you haven't met that before. Important to note that's possible. So let me set up a similar table to above. What's changing? We've got iodine. Don't need that too. Just for each atom, count for what each atom is doing. Iodine going from 0 to -1, and we've got sulfur going from +2 to +2.5. And again, I'll have a column for difference, column for a ratio, column for balance. So the difference is we've got a gain of 1 and we've got a loss of 0.5. So 0.5 and 1. And balance, let's see what we've got in the equation. We've got 2 atoms of iodine there, so we need at least 2 there, but we've got 2 atoms of sulfur there, but over here on the right we've got 4 atoms of sulfur. Okay, so we need 4. And then because this ratio is established per atom of iodine and sulfur, as in we need twice as much sulfur as there are iodine atoms, we need to multiply both numbers in this ratio by the same thing to keep that ratio effective or constant. And then, so how many atoms do we have in total? How many atoms of iodine? Well, we've got 0.5 by 4 is 2, and 1 by 4 is 4 atoms of sulfur, left and right. So 2 atoms of iodine, we've already got 2 there on the left. Oops, daisy, I pressed the wrong button there. Undo. So I need 2 and 2. And now 4 sulfurs, so I've already got 2, so I'm going to put a coefficient of 2 there, and we've already got 4 on the right, so that's fine. And now let's check everything else is okay, or let's see what we have to do to make it okay. Iodine, sulfur, and oxygen, no hydrogen. Okay, iodine we've done 2 and 2, sulfur 4 and 4, oxygen we've got, how many oxygens do we have? Let's say 6 here on the left, 6 on the left, and we've actually got 6 on the right there as well, so that balances. Okay. Oh yeah, hang on. Wasn't there one part we need to do? Yeah. That's why it's worth underlining, just to kind of make us come back for it. need to use oxidation numbers to identify the species oxidizing the first reaction and oxidizing reagent in the second reaction. Well, the oxidizing reagent is itself reduced. So what is reduced? And I'm remembering that reduction is gain of electrons. What's gaining electrons? Iodine's gaining electrons. So that is the oxidizing agent, I2. Okay, and you must put in the subscript there to get full marks. That's the oxidizing agent.